So question 7 says find the LCM of the given polynomials. So we have 16x to the 5th minus 8x to the 4th is plus x cubed is one of the polynomials. And we have 4x squared minus x is another polynomial. And then the remaining one is this x to the 4th. Now, as far as least common multiple goes, if I'm looking at, say, 6 and 4, if I want to find the least common multiple of these numbers, you'd have to list the multiples of 6. So like 6 times 1 would be 6. 6 times 2 would be 12. 6 times 3 would be 18. 6 times 4 would be 24. 6 times 5 would be 30. So that would be listing your multiples. The multiples of 4 would be like 4 times 1 is 4. 4 times 2 is 8. 4 times 3 would be 12. 4 times 4 is 16. And 4 times 5 is 20. And the multiples would keep on going. So notice that if I just look at this, you can kind of see that 12 would be the common multiple and it would be the smallest. So the least common multiple of a 4 and a 6 would be a 12. Now, if I was doing something a little bit bigger, say I wanted to find the least common multiple of, say, 18 and, say, 27, let's say, make that a 42. Something different there. Notice that when the numbers are a little bit bigger, it's harder to list the multiples. So this is where you can actually use prime factorization. So if I look at the prime factorization of 18, so remember we have the 2 goes in 18, 9. 3 goes into 9 3 times, and 3 goes into 9. I'm sorry, 3 goes in 3 1 time. So 2 times 3 times 3. So in other words, 18 is the same thing as 2 times 3 squared. If I look at 42, we would have 2 goes into 42 21 times. 3 goes into 21 7. And 7 goes into 7 1 time. So notice that 2 times 3 times 7 would be that. So if I want to do the least common multiple, what you have to do is identify the different factors. So notice that there's a 2 is a factor that's in common. Well, it doesn't have to be in common. It's just identify the different factors. So a 2, there's a 3, and a 7. So you just list the different factors. So when it comes to the least common multiple, remember, the smallest multiple of 18 is a 2 and 3 2s. So I need the 2 and I need the 3, the 2 3s. Notice that the 42 only needs 1 3. So the most 3s I need really is just 2 3s. So notice how I'm merely just choosing the bigger exponent one. So the 2, this needed a 2 and this needed a 2. So all I needed was 1 2. For the 18 to exist, though, I still need 2 3s, and I've got that. For the 42 to exist, I need a 2, a 3, and a 7. So I only need 1 2, 1 3, and 1 7. So even though, there's not a 7 in common, remember, in multiples, I'm trying to create the 42. I have to be able to see the 42 down here. And also I do see a 2, a 3, and a 7. So when you do a least common multiple, what you're going to do is list the different factors and then identify the most that you need to create the multiples. So if I put this all together, that's going to be like 2 times 9 times 7. That's going to be 18 times 7. So 18 times 7, that's going to be the least common multiple, which would be 126. So we're going to be kind of using these same a strategy. So notice how to find least common multiple when the numbers are a little bit bigger, I'm using factoring. So if I go up here and use factoring, notice that the first trinomial has an x in common, but notice how it has an x cubed in common. So I actually can factor out an x cubed. So if I factor an x cubed, the 16 is going to remain. This is going to give me an x squared. And this is going to leave me just one of the x's. This is going to be a minus 8x. And then since I pulled all those out, x cubed divided by x cubed actually just leaves me a 1 in that place. So if I multiply x cubed times 16x squared, notice how that does give me 16x to the 5th. Minus 8x to the 4th. Notice how I pulled out 3 of the x's. That just leaves me 1x. The 8's still there. So that would be that. But notice that this 16x squared minus 8x plus 1, looks like that's got to be factorable. So what I'm picking up on is this 8x, this 16x squared is a perfect square. So what if I still got my little shortcut here? So if I look at this formula sheet here, this little strategy sheet, if you will, let me kind of see if we can move some stuff around a little bit here. Get this over a little bit. Notice we pulled out the GCF already, but when it comes, notice how if there's a perfect square trinomial, this looks like a perfect square trinomial because if you look at this 16x squared, that's really going to be 4x. So 16x squared really is 4x squared. That's going to be a perfect square. 1 is a perfect square too. So to be a perfect square trinomial, notice how this is kind of the second one here because there's subtraction involved. I can write the first part as a perfect square, that would be 4x. I can write the last part as a perfect square, that would be 1. Now the catch is, to get the middle term, you have to multiply this 2 times this a times b, and it's got to give you the middle term. So if I multiply the 4 times the x and then multiply it by 2, so if I have 2 times 4x, does it give me this 8x? And also that is my middle term. So this is actually a perfect square trinomial. So this is going to factor into then, this is going to be x cubed, and then this is actually going to factor into 4x minus 1 squared. So that's kind of how that one plays out there. So that can bring this back across here. So if I look at the next polynomial, is it factorable? It looks like they both have an x in common. So I can pull an x out. I can pull an x out. And if I do, this is going to give me a 4x. And this, remember, x divided by x is going to leave me a 1 there. So this is going to give me x and then 4x minus 1. So this last thing is we have an x to the 4th. So it's really not, it's just a monomial. So if I want to do the least common multiple, what you do is you identify the different factors. So what I'm seeing is there's an x. What I'm also seeing is there's this 4x minus 1. Now the catch is, this first one needed 3 x's, this one needed 1x, and this one needed 4 x's. So again, I have to use the x to the 4th because this is the first multiple of this monomial, if it was x to the 4th. So I have to choose actually the biggest exponent because I need all this. So I don't need x cubed, x, and x to the 4th. I just need the maximum number of x to the 4th that are present. So 3, 1, 4. I need 4 as my exponent there. If you look at the 4x minus 1s, this one had 2 4x minus 1s. This one had 4x minus 1s. So I need at least 2 4x minus 1s. So I need a power of 2 there. So my least common multiple is actually going to be this x to the 4th times this 4x minus 1 squared. That's kind of how we do that. So we have to factor, and then notice how we actually use the biggest exponent actually of each. And that kind of creates our LCM.